All right. Welcome back, everyone. Good morning, good afternoon, good evening. Hello, if you're just joining us here in the architecture track. It's so exciting. Even my cat has decided to make a rare cameo sitting behind me here as we get ready to kick off the afternoon stretch. We're almost there, friends. And I know we've got plenty of content for you here today and tomorrow, but I did just notice that Mandalorian season 2 is coming out October 30th. So we have that to look forward to here. But before we get to that, I'm delighted to have a bevy of our good friends from Amazon here to talk about how can we make machine learning work inside our Spring apps. So without further ado, I'm going to turn it over to, I'm just going to call you the four horsemen of Amazon. That's probably faster than me trying to roll through everybody. So I'll turn it over to you folks. Have at it. Thank you so much.
Hello, everyone. I'm Mikhail Shapirov. I'm a senior partner solutions architect at AWS. And my domain is containers, products and apps that run on Kubernetes, EKS, ACS, App Mesh. Before becoming a solutions architect, I was a senior software development engineer at AWS as well. And before that, I was an engineer, software architect, enterprise architect, platform architect, different roles, but mostly an engineer. So I started using Java a long time ago, many years ago. I don't really want to say how many years ago, to tell the truth. And started using Spring in about 2005. I think it was a 1x version of Spring at that point. It was very pleasant for me, a very great experience. I produced a couple of my own frameworks, IC and ORM. For some reason, they didn't take off as prominently as Spring. But I'm very happy to be part of this conference. And today, together with my colleagues, Herman, Qing, and Vaibhav, we will show you how to integrate machine learning into your Spring Boot application in less than an hour. Well, to tell the truth, it's only going to take a couple of minutes to integrate machine learning into your Spring Boot application. So just really briefly about the format, I'll talk about machine learning in general, what we observe in the field. We will discuss DGL, is a deep learning Java library, a quick introduction, present a couple of real case studies, how we use it here at Amazon in production. This is done to assure you about how much love we give this library and it's scalable and supported. And then we'll talk about how you can use deep learning in a Spring Boot application and also take a look at the demo with the deployment to production, hopefully covering engineering, architectural aspects, and development aspects. So at AWS, our mission is to put machine learning in the hands of all developers and organizations. That sounds easier said than done. And I think the key word here is not necessarily even machine learning and not developers, but the key word here is all. So how we approach it, we're going to discuss in the next slides. Machine learning in 2020 is huge, and it's a top priority for many organizations. They have their strategic goals aligned with machine learning. We are in an unprecedented time right now. In the past, we observed that it was engineering and data science leading the way. Like engineering comes up with this cool neural network and trying to push it to business to see if there is a use case. The amount of compute was limited. Now the amount of compute is almost unlimited. We have business driving the use cases such as fraud detection, in the natural language processing. There are many new terms that entered our vocabulary: pose estimation, sentiment analysis, etc. All became quite common. There are some common challenges with machine learning adoption: skills gap, just not enough people who know it. Machine learning is a time-consuming and complex process, takes time and skill as well. And then sometimes even finding the right business use case is a challenge. Sometimes either the use case is not right or the approach or algorithm model that was selected by the team is not right, and projects fail. So our mission is to make it easier to build, make it easier to scale, and make it easier to apply. So whenever you see a use case that is good for machine learning, we try to make it easier for you to apply it in your application. And your application might as well be a Spring Boot application, a Java application, whatever you have right now. Well, this slide just shows the breadth and depth of the services that we provide for machine learning at AWS. They're separated, divided in three layers. The top layer, I'll start with the top, is our AI services that they use pre-trained or auto-trained model. You can see recognition, translate, transcribe, and things of that nature. They can be used by anyone who can use APIs. Then there is this middle layer. It is for machine learning developers, for data scientists, for people who know what they're doing. It just makes it easier to run common activities around machine learning, which, for instance, with SageMaker, there is an IDE. You can debug, you can run experiments, you can apply hyperparameter tuning and things of that nature. And then there is this bottom layer. It's for experts, contains machine learning frameworks and infrastructures for people who want to have full control over their applicational code, applicational logic, as well as full control over their infrastructure. And you can see popular frameworks like TensorFlow, MXNet, PyTorch from AWS, and Amazon in general supports all three of them and contributes to the open source projects, as well as we decided to create one more library for that in the same spirit, open source. The DGL library is just that. It abstracts away those three. And in the same spirit, it is made open source and shared with the community. So here it goes into this abstraction layers along with Gluon and Keras. Along with that, so let's move on to the deep learning in Java with DGL. And Qing, please take over.
Yeah, thanks, Mikhail, for introducing Deep Java library here. Hello, everyone. My name is Qing Lan. I'm a software engineer inside of Amazon Machine Learning, and I'm also the co-author of this Deep Java library. So let's go ahead with the next slide. Yeah, so basically, let's try to answer the first questions. What is Deep Java library? Deep Java library is a machine learning framework that's been designed and implemented inside of Java. It has most of the machine learning features, including the training and inference. It also has the Java features, including the multi-threading support and also the built-in memory control mechanism. And Deep Java library has been designed into the engine agnostic way, where you can just like the definition for Java, write once and run anywhere. It can leverage on top of different deep learning frameworks such as MXNet, PyTorch, and TensorFlow. It's been benefited by its unified API, where you can leverage that directly, and it's very easy and very easy to understand. And it has surprisingly same behaviors while you're trying to use the same API while you're trying to leverage with different deep learning engines. And for a quick example, if you want to try to run inference on a PyTorch model with the same configuration, you can easily switch into another deep learning engine. For example, you want to run the similar models with TensorFlow, you basically don't have to change much of the code, and all you need to do is change your own dependencies. Another feature that Deep Java library have is the model zoo support. It contains more than 70 different pre-trained models where you can use them directly for your own inference and training tasks. And currently, the source of the models came from different parts. Well, some of them came from the Gluon CV model zoo. You can also import from Hugging Face, Keras, and also Torch Hub, because thanks to the different support on deep learning engine. And the reason why we presented Deep Java library is throughout the contribution with the different deep learning framework inside of Amazon. We're actively contributing to TensorFlow, NumPy, MXN, and PyTorch, and also many more different machine learning frameworks. From the experiences into this kind of the open source contribution, we gradually learn and understand what are the bottleneck for the machine learning and deep learning in the production needs. So that's why we're trying to invent Deep Java library here to solve the problem. Okay. Next slide. So deep Java library is designed to be very simple, which means you can write you can use them directly, even if you really don't have much of the machine learning or deep learning knowledges. And just saying this part, deep Java library has the model zoo support, contains a different model where you can actually apply them that directly by creating a very simple pre-processing and post-processing stage. On the left-hand side is actually a doodle draw recognition application. This is a model that can actually recognize the doodle drawn by different people, like the rabbit you can actually see on the left-hand side. And below that is actually an image classification that's implemented inside the PyTorch and running on top of the Android device. You can also run this in your PC device. And for the core inference code of these applications, it's only less than 20 lines of code. So it's very easy to integrate. And it has the same behavior while you're trying to run inside of the Android device or a PC platform. They have the same API and also same level of support. Yeah, next slide. So, and before we actually go into the benefit part, let's try to firstly understand why you should try to leverage deep Java library here. The first part is because it's very Java friendly. The initial reason why deep Java library came into part because there are actually teams in Amazon finding it really hard to integrate their machine learning models into their existing serving platform, mostly done inside of Java. They have to choose like two ways to go. First one, they have to maybe maintain some kind of GNI in order to call the C API from different deep learning engine, or they will have to end up writing the Python process in order to call the Python package for this machine learning and different deep learning product. It costs the things is running slow inside of their server, and also it's hard to maintain the packages because there are random crashes happen when they want to launch the different services. And the second reason is because the Java community really lacks a deep learning standard in most of the cases. While you're trying to leverage like different machine learning or different deep learning packages inside of Java, you will find it really hard for you to find them have the consistent input and output between different packages. So deep Java library trying to maintain a single standard such as very similar to NumPy as most of the currently deep learning framework choice. So which means you will have similar experiences from end-to-end deployment, no matter in training and inference, and no matter which kind of different deep learning engine you're going to use, they will all have the same experiences. And the final reason is because the Java itself is really easy to understand and is very reliable during your service code. Especially you would like to have the good error handling and as well as the really good understanding while you're trying to integrate that piece of code. And the deep Java library is a natural fit since it's been designed in Java and also has all the Java standard features for error handling. Yep. Next slide. Yeah, and let's talk about the key advantage of deep Java library. Firstly, it's very easy to set up. In just 10 lines of inference setup, you can have your whole inference work done in your process system. And it has a very small dependency requirement. For example, if you're trying to leverage TensorFlow CPU, it will only cost around like 200 megs of the disk space, and also in a total of only 3 packages you're going to import. And it's very fast. It can get up to 2 times performance boost on small model inference. And the term of the small model here means the model with less of the features. For example, if we have a SqueezeNet, we have benchmark SqueezeNet, it can get up to do 2 to 5 times performance boost on an inference server. And this kind of technology has been used widely by Amazon Ads and Query Understanding team to leverage with the service that has a really tight latency requirements. And the deep Java library has also been applied into a very large scale. We have teams running deep Java library with Apache Spark on a very huge data set, more than 800 million data set, and it can do the offline distributed inference in just 6 hours. And the deep Java library also support for online streaming. That's also thanks to Java, because most of this kind of package are implemented in Java. So deep Java library can be a really easy integration, like a middleware to do some machine learning and deep learning tasks. And DGL is also very stable. It ensures like 100%, 100 hours benchmark test in every of our different version, which we make calls into the inference server all the time, to ensure it won't crash. Next slide. Yeah, in order to get the Java developer closer to deep Java library, we actually implemented the two amazing tools. One is the JShell on the left-hand side, where you can just type in the Java code directly through all the terminal style stuff. And on the right-hand side, we created some toolkit where you can just put your inference code on the right-hand side and run the live inference. And also using different deep learning engine, you can switch between MXN, PyTorch, TensorFlow. And after this part is done, you can just grab the template and run everything locally. And these are all available from our website. Yeah. And finally, next slide. Deep Java library has the support for training. It has the MXN and PyTorch engine support for the training, and it has most of the data set and the models for CV and NLP work. And you can run your training work easily with Deep Java library. And finally, Deep Java library has another part of the advantage where you can just leverage all your code inside the Jupyter notebook, which is known mostly in the data science world, that you can quickly prototyping your model training and inference tasks in just one file without configuring the environment. Yeah, and in the next part, I'm going to hand over to Herman to introduce the actual use cases that are used by Deep Java library.
Yeah, hello. My name is Herman Birkmeyer. I'm a senior engineer in Amazon advertising here in Seattle. Can we go to next slide, please? So let me introduce Amazon advertising real quick and how we use machine learning and DJL. So Amazon advertising is an offering that we have for sellers and advertisers to promote their products and brands off and on Amazon pages. We have multiple offerings in that space. I'm specifically working on sponsored products, and sponsored products is our offering for sellers to make their product stand out in, for example, the search and the product pages. If we take a look at what this looks like on the next slide, we see that we have here a search result. And the way this is basically the sponsored content within the search result here. The query was, I think, for teddy bears. And then let's go to the next slide. And one thing that we need to talk about is how is ML used in generating this content? How is it used in Amazon advertising? And we have hundreds of models that we run globally for use cases like click-through prediction. Many innovations in advertising require the use of ML, and we have new models and new teams emerge constantly, and they come up with requirements to host their models for us. Different teams prefer different ML frameworks. That's just, I think, a fact of life. We have that all the time. And we talked about kind of why choosing Java for hosting the model. So we have a Java-based model hosting service, and it allows us to use modern software engineering techniques like strong typing and dependency injection. And it's also well integrated with our operational safety frameworks that we have here at Amazon. So that is why we're having this built somewhere else and host in Java. So if we go to the next slide. So with that, how does DJL help us? With DJL, we really can offer a choice to our scientists. We can run these different ML frameworks and models in these different ML frameworks side by side. And then any new capability that DJL gains, we will be able to support those models right away or with very little effort. And then the other thing that I would like to point out is when we talk about ML models, one part that almost nobody talks about is DJL translators in the feature generation step. So feature generation meaning you get a request and you have to provide inference, and then there's a step to transform basically your incoming data to the to what the model takes as an input. And DJL has the translators kind of concept there that allows us to keep our feature generation independent of how the model is implemented. And that works very well for us because we had a feature generation framework already that was independent of the models and the model technology. So that worked out very well. So all of these things, there are great advantages for us to use DJL in advertising. So with this, I hand over to Vaibhav to talk about other use cases.
Yeah, thanks, Herman. Hello, everyone. My name is Vaibhav Goel. I'm a senior engineer in Amazon Customer Behavior and Analytics team. And our aim is to provide best-in-class targeting to any Amazon product or service to drive customer engagement. And one way to do that is like we provide personalized marketing to customer via different channels like email, showing ads on social channels, and banners on Amazon Retail. To provide these personalized marketing content, we first identify customer propensity to take action across various products within Amazon. And that's where like machine learning come into picture. If you can move to next slide. So we use multi-label classification model built on top of MXNet for these models, and we have a single model with thousands of product categories. So we use a single model with multiple output nodes, where each node represent propensity for each product category. And now let's talk about like the key challenges like in our domain. So there are like two challenges. One is like we have like very high dimensional feature data. So there are hundreds and thousands of features per customer, and there are like hundreds and of millions of customers. So we need to generate these predictions. And we wanted a solution where we can scale well for these high dimensional data, and also use like large model with like thousands of output nodes. And our team consists of mix of software developer, engineer, and research scientist. Our science team prefers to use Python based frameworks, while engineering team prefers to use Java or Scala based framework. So this posed another challenge while we were deciding should we go ahead with Java-based frameworks or Python-based frameworks. And DJL helped in overcoming these challenges. Next slide, please. So now, as DJL is ML framework agnostic, and it doesn't require you to build model on top of DJL for you to run inference. So you can use different frameworks, different Python APIs to build your model and still use DJL for running your inference. So now with DJL, our science team can use MXNet Python APIs to build model and run their experiment. And engineering team uses DJL to run inference using Apache Spark in Scala. We are using Scala, and DJL provides Java-based APIs which are easily integrated in Scala as well. And this gives us decoupled our system from ML framework. So now our science team can try out TensorFlow or PyTorch in future without engineering team to worry about how to integrate that. So all those things are abstracted by DJL. And it helps us like handle our high dimensional data, and with our big model with like multiple output nodes. And when we integrated with DJL, we found like our batch inference time was reduced by 85%. Before DJL, it used to take 24 hours, but with DJL, it takes around 3.5 hours with same hardware. So definitely like DJL has done some performance tuning, and just by integrating that, we'll get a lot of benefit out of that. So that's mostly from my side. I will hand over to Mikhail.
Oh, thank you, Vaibhav. It was all great stuff. Really cool use cases showing that it's can be applied both for streaming apps, for batch jobs, and a variety of other use cases. So now getting to the main meat of this presentation is a DJL Spring Boot Starter. It provides a more native experience with DJL or for Spring developers, and it handles dependency management for inference and handles auto configuration options, which is fairly common for any Spring Boot Starter. So we started with our partnership with Pivotal, and one of the objectives of that partnership was to see if DJL is going to work well on PCF, on Pivotal Cloud Foundry, and actually it does work well. And the demo that I'm going to show later still contains the deployment manifests of PCF deployment, but I'm going to show you how to deploy it to EKS as well, since it's standard Kubernetes, and Kubernetes currently covers pretty much every platform there is. So dependency management is a separate kind of artifact of the Spring Boot Starter. Hopefully at some point it will be part of the Spring initializer, and you will be able to just easily consume it when you start your Spring Boot apps. Within that, you can see a few details. It's a standard one. It derives from a starter parent. We use GNA. The version of GNA should be bumped up a little bit compared to what's in the standard BOM for Spring Framework. And we cover engines like MXNet, PyTorch, TensorFlow. You need to select the engine that you will be using. So there is a starter for MXNet. There is a starter for PyTorch and TensorFlow. So that decision has to be made at build time rather than runtime, but no other changes to the code are expected. You can change it without changes to your code and test each one of them. You can also see in this specific case, there is a platform indicator like Linux A64, and that basically also an indication of the target OS architecture where you want to run it, but there is also an auto dependency. And auto dependency is similar to this example as in Gradle. In this case, I'm implementing dependency on PyTorch. And instead of specifying my target OS, I'm specifying auto. That means the library will detect the environment itself and download the artifact at that point based on what's detected, if we obviously support it. And we support Linux, we support Windows, and Mac at this point. So there is a auto configuration component, which basically wires some of the components for inference for you. And those components, this component is separate from the starter itself. It was a conscious decision. We did it for a couple of reasons. One is that some developers prefer to have full control over configuration options, and they may not want the auto magic, so to say, although it's really cool when it works. It's not so cool when it doesn't. And in such cases, the starter can be used just as in the dependency mode to support the set of dependencies in a single as a single artifact. Another reason for that is that auto configuration is generic for all kinds of DGL configuration. It doesn't really depend on the underlying deep learning engine or operating system. And developers can swap those engines, but they don't have to swap the auto configuration. You can obviously expect standard support for application YAML application.properties in your Spring Boot with that. Access to the models allows you selection of application types for inference types from the following list, and this list is going to be growing. So users, you will just apply standard configuration. We have also IDE support for that. That's how a generic configuration is going to look like. And let me just switch quickly to the IDE. Hopefully you can see it. That's the example of the YAML configuration for the model that Qing was showing with a Doodle application. You can see that I can specify a URL and just point it to a specific model that if I know exactly what that model is, it will just load that one. If you don't specify the URL, Then depending on what you indicate as filters, well, let me just delete all of that. Let's use, depending on your filters, it will load the right configuration from the model zoo if you have of the right model. So we start with DGL, you can go to selecting your model filter to application type. And it's going to show you all the application types that it supports. So maybe you're just starting with this library. You don't know exactly what the model is, whether it's a residual deep learning convolutional network model that is used, or is it you just know the use case that you have in mind. And that was the idea behind this configuration. Maybe you want to have a pose estimation or some object detection, which we use. And in this case, the next you define some input class. Let's say it's going to be some kind of image. Maybe the output class is going to be something else. Those are required artifacts. The rest of that are just arguments that are passed to the repository that retrieves the model. And here you can maybe specify something like a threshold, 50%, deliver results that exceed 50% in probability whenever objects are detected. So going back, one of the biggest constructs, or the main constructs in this starter is a predictor. That's for inference, at least. That's the one that will be used to really run your inference. After you use this auto configuration, you just expect to inject the predictor with the input and output type. It is injected as a simplifier. I'll talk a little bit about it later. There is an image factory that is also a convenience factory to work with images. And after that, you can use a try with resources for a predictor. The reason for that is you need to understand that we use native code behind the scenes, and we use a JNA adapter. We allocate memory off heap, and it can leak. So it is very important to not get a code that leaks. And with the supplier approach and try with resources, you use language constructs that effectively take care of those problems. However, you can use it in a multi-core architecture. You can run it in parallel and in the multi-threaded mode, and all of that is going to be possible. This construct is not thread safe, so just use a supplier. You can also use an auto proxy, but we thought that supplier is just a little bit more explicit. The next step is we can containerize your Spring Boot application, which is Spring Boot is quite good for containers. And in our example, we're going to use Jib for that. It's distroless plugin for Gradle and Maven, which can produce a container image without the Docker daemon running on your machine, or with it if you prefer it that way. And the important part here is that we will also add the commit hash to the, we will add it to the tag so that it can distinguish that specific image from everything else. The CD cycle, which is a continuous deployment cycle, is straightforward. We're going to build, upload to container registry. In our case, it's going to be Amazon ECR, but you might as well use Docker Hub or whatever you prefer, and run it on Kubernetes with EKS or ECS. We use GitOps for deployment. And one of the reasons is just we don't want to spread credentials. It's just easier that way compared to imperative. We have two teams. Let's imagine that use case. We have two teams. One is developing API that runs inference. The other one is developing a web application. They have their own namespaces in Kubernetes. They want to interact with each other. And another namespace is used by our GitOps engine. In this case, RPC. Okay, I'm going to stop this demo for a little bit. And we'll just look at the IDE, which is, I think, what everyone is expecting. So a little bit about the components. Spring Boot app, DGL Spring Boot app is the API that runs inference. Spring Boot web is the application that has a web UI, consumes that API. This is a tiny component that shares the API contract, like an SDK. And this component has some common libraries shared across those two. Amazon client configuration, connection to S3, things like that. We have dependencies defined here. You can see that currently this project, the app project, the API, that's the one we're going to look at, depends on MXNet. That's the deep learning engine that we utilize at the moment. And with that comes the model zoo. And it is deployed. So let's take a quick look at what it is, where it's running, and at the Kubernetes cluster where this deployment is running currently. So as I mentioned, we have a few namespaces. One is for one team, the other one for another, and then there's one for the deep learning. For the GitOps engine. And let's see what results we can get from it. While the stock image that we use produces very good results, you can run this. Let's say you take this image of the dog and the bicycle and the truck, and it recognizes it. I wanted to show what real experience for developers is going to look like when the results are not as glamorous as the prepared image. But let's try it with the regular street view. That's what I want to use this computer vision for. Street car plus truck. We have just a standard street view. I'm just making it a little bit bigger so that you can see. And let's see the results of this inference. It recognized this bus. There is a car here, and it took this truck as a bus. It does resemble the bus a little bit. So if this model never saw a truck, then it might as well approximate it to this. The results are okay, not great. Let's take a little bit more challenging example, which is various objects. They're like hand-drawn, like sketches, rather than real pictures, images. And let's observe the results from this specific model. And you can see the results are, for some reason, it labeled a lot of objects as chair. And one is a TV monitor. And this one is sort of like a chair, but I think it's a broken clock is right twice a day. So if you label everything as a chair, then maybe you're going to be right sometimes. So the results are pretty bad. Let's try and modify this application and change it so that we're just investing in. I'm a new developer, and instead of changing the model, which is the right thing to do here, I'm going to change the whole deep learning engine and switch to PyTorch. Yeah, by the way, it's important that this from image, we're running Debian cluster. It is sensitive to what you're running, because we're using native components. So be careful with that. So Alpine is also on our roadmap. So we changed this, and let's also, we are using actuator. So let me change the actuator endpoint a little bit to make sure that with PyTorch now, since we switched to PyTorch, and I'm going to run the build. So G is my shortcut for Gradle. Let's do boot jar. Standard command. Hopefully it will run quickly. Sometimes it does, sometimes it doesn't. And the next step will be, we'll containerize, because we now have this new image that is using PyTorch instead of MXNet. It is running a little longer than I expected. But okay, 20 seconds. So I'm gonna run Jib now. And it's pushing the layers, as you see. And done in 15 seconds. That's pretty good. I think it's both. It's a complement to my network and to Amazon ECR as well, for that kind of support. So from this, you remember I mentioned this commit hash. We do need that because now the image that we currently have in our container registry has a different hash. I want to deploy it, and I want to reference that specific image that we just produced. So in my deployment file, this is a regular deployment YAML file from Kubernetes. You see that I'm using this v1, v4. I'm going to replace it with this hash right now. And we will have to commit that change. So let's enter git commands, git status. Yes, this is changed. So we will add on YAML and and push. Normally, you would probably have some kind of a process, some pull request, but this isn't push it directly. Let's see what the current actuator endpoint is producing. Right here. So the actuator is producing just DGL Spring Boot demo API. Doesn't have this PyTorch thing. In order to really apply this deployment, although it could have been done in the automatic mode, we need to synchronize through the GitOps engine. So it did detect there is an out of sync state. The state of the application in the Kubernetes cluster is different from the state declared in the Git repository. And I'm just going to run this synchronization. Let's now synchronize. And switch here. Let's take a look at our deployment. That's again, I'm just using this Kubernetes Explorer. You can see that one container is terminating, it's the previous one, and a new container is coming up as we speak. Now it's running. That's great. Let's give it another try and see if the actuator actually picked up our change. You can see that there's a DGL Spring Boot demo API with PyTorch. That means it's deployed. Let's give it a try now. We're going to get better results. That's what we're hopeful to achieve. So in order to run inference again, I'm going to just select those objects from my local drive and submit them again. The upload is running, and we will see the API results, which are textual results, as well as the image. So the API results show truck, car, and another car. Let's take a look. Yeah, definitely better result. Detected this as a truck as opposed to a bus previously. Many more labels, cars, and the interesting thing is that you can also see people inside the bus. I wasn't able to see that first because of the glare, and it can see those people, and I can also see that it labeled one of them as a son, probably a son of one of the people on the bus. So it's obviously it's a joke. It's just a label overlap, but I think results are much better than we expected. I'm sure there is a way to improve it even further. Like for instance, this is not a traffic light, but it is at least it's a pretty realistic result. Now let's try the same thing with this horrible image, which was various objects that didn't really work well for us before. Meaning done. And yeah, definitely better results. Spoon is detected correctly. Sports ball detected both people, even though they're hand drawn. And scissors, well, that's space for improvement. I like the fact that this Morse key is detected as a cell phone. I would like to think that, for lack of a better term, it just tried to approximate it to the nearest communication device similar in shape and showing it as a cell phone. Well, hopefully, that opens up an opportunity for the roadmap for DGL, which is there a way to just take this model and start using it? It may not produce the best results, but I just want to train it a little better, a little more, maybe apply some transfer learning or something of that nature, and get 100% results. And that's what we're going to be doing later, and hopefully in the next conferences like that as part of our roadmap. And with that, I'm going to stop the demo and just switch back to our presentation. Second. Okay. So, talking about the roadmap, DGL Spring Boot, what is next? We will continue to integrate DGL functionality. So as soon as DGL versions go out, we're currently on 0.6, we will be integrating them. That's business as usual. We'll hopefully include, not hopefully, definitely include training and transfer learning with DGL Spring Boot Starter. We'll create solutions, workshops with full CI/CD, training, inference, feedback loop, and multi-tenancy. It's possible to apply it on a Kubernetes cluster such as EKS with the GPU-optimized instances and inferential chips, etc. So there is definitely quite a field for improvement for us. Qing, if you would like to talk a little bit about DGL future itself.
Yeah, so talking about DeepDraw library in the futures, we're going to have more of the Android support. Currently, we already support for Android inference, and now we're going to move on to support the training on the Android devices, and also the inference support on the more of the engines. Another key of things we're trying to get in here is a Java version. The first book introduced deep learning in Java by leveraging the existing Dive into Deep Learning book. And now this one is available for our preview version. It's available from our website where you can find it. And and also we're going to have the DeepDraw library integrated with more of the Amazon Web Services, including EMR Lambda and much more of server-based or serverless application. And we also trying to lean towards into newer directions to getting the reinforcement learning and federated learning with DeepDraw library. And finally, we're going to have a better distributed inference and training support with DeepDraw library. Currently, we're supporting the distributed training, and we're trying to leverage that with more of the use cases with the GPU support. Yeah, that's pretty much.
Great. So at the end of this presentation, I added a few references, some resources and documentation. The DGL.ai is a really great website. You can also see the demo that Qing was showing with Doodles. It's possible to run the demo with Spring Boot and just a few lines of code as well. It shouldn't be a big problem, and then we demonstrated previously in the YAML file that was the configuration for that one. The source code that we used here, obviously DGL source code is all open source. Please take a look, and if you would like to contribute or would like to take it in a specific direction, don't hesitate to create an issue. We have also a Slack channel for DGL dedicated to those users, and we have quite a bunch of users there, a number of users there. You can be one of them. The starter itself that contains a simple demo app, as well as the demo application that we observed, like microservices, API, web, both Spring Boot applications are also available on GitHub. And if you would like to play with it, please do. And I don't know, hope maybe the deck will also be part of the materials that distributed after the session. If not, it's currently on screen. We were a little bit kind of like frightened before when we were told that if you're not exactly on time, you're going to be cut off. So I think now we just ran a little bit faster through the content. There's plenty of stuff that we can talk about in terms of DGL and deep learning in general. I hope that it was an interesting session for you, and we'll continue to do our best to make it easier for Java and Spring developers in general. Thank you for your time.
Thank you.
All right. Well, thank you so much, friends. Really appreciate all of that, and thank you for coming inside the time slot. I know it's a harsh thing. We got to keep the trains running on time. That's what they have been harping on us in the MC and production side of the shop. So thank you guys for bringing it in there. I was talking with my friend and colleague Cote about this actually on Monday. It's just really exciting to see these bigger abstractions being available and how things are getting. I don't want to say maybe easier. That's probably a little glib, but it's simplifying our ability to do some really cool, interesting tech stuff. And so I really appreciate you guys giving us some insights there. Well, friends, one more session here in the architecture track before we kick over to the main stage. So we'll take a bit of a break here, stretch your legs, fill up your beverage of choice, maybe grab a snack, and we'll have one more talk here. We've got Tola coming up talking about saga pattern and spring state machine and cool stuff like that. Excited about that. And then it'll be time for the main stage. For those of you that still want to talk more about machine learning, and who doesn't, you can follow us over into the Q&A Zoom. And I know there's actually been quite a bit of chatter on Slack that you guys have about your presentation. So there'll be some more opportunities to continue the conversation. So with that, we'll go ahead and take a quick break. Thanks, everybody.